Good morning and good afternoon for everyone joining us for this webinar. We're just close to getting started, but before we actually get started right at the top of the hour, for those that join early, we want to show you a little bit of a primer about the topic at hand, which is Skydio 3D scan. So with that, I'm gonna leave you with an exciting video of what the 3D scan software can do.
Right, that was a really exciting intro video. Welcome everyone, and thank you for joining us for today's webinar, Skydio 3D Scan Masterclass, Get the Most Out of the World's Leading Adaptive Scanning Software, brought to you by Commercial UAV News and sponsored by Skydio. We have a few housekeeping notes to go over before we officially get started. If you have any technical questions or any issues using the WebEx platform, please use the chat box and I will respond right away. If you have any issues with audio, please click on the phone icon above the chat window to receive the teleconference information. And for those that do call in, to ensure call quality, everyone's lines have been muted today. And we encourage you to ask questions throughout the presentation. Please type your questions into the Q&A box and select all panelists when submitting your questions. And our presenters will answer these questions at the end of the presentation today, but please do not hesitate to ask them during the presentation as they occur to you. And this webinar will be recorded and you will receive a thank you email with the on-demand materials within 2 business days. And with all of that out of the way, I would like to welcome our speakers and hand the webinar off to the Skydio team.
Thank you, Kelsey. I'm gonna get going here. Again, thanks everyone that is joining us. Good morning, good afternoon. My name is Mauricio Barra. I lead the product marketing team for everything enterprise and public sector here at Skydio. And I'm gonna be joined by two gentlemen. First one is Brian Richman, our product manager for Skydio 3D Scan, and Peter Kalatzidis, UAS program manager for the New York Power Authority. So I'm gonna let them introduce themselves a little bit here. So Brian, do you want to go first?
Yeah, thank you, Mal. I'm Brian Richman, Senior Product Manager at Skydio, predominantly focused on all things inspection to include Skydio 3D Scan. I've been in the drone industry now for about a decade, starting with an early sort of career in the Department of Defense, where I accumulated about 1,000 hours testing large military aircraft. I've spent the last 7 or so in the commercial space, and the last three and a half of that at Skydio building 3D scans. So I'm excited to speak to you all today about what we've been able to accomplish. Peter?
Good afternoon, everyone. My name's Peter Kalaitsidis. I'm UAS Program Manager for New York Power Authority. I've been in drone robotics industry for about 10 years now, from companies like Easy Aerial, DJI, and now I'm here creating New York Power Authority's drone program.
Great. Thank you, Peter. Thank you very much. So with that, basically, I'm going to start by explaining how we're going to do this for this webinar. So we're going to kick things off with me giving a little bit of an overview about Skydio and our products, because we want to make sure that if anybody here is new to Skydio, is new to our webinars, I want to make sure that you're not lost and you get the basics of how Skydio works, what makes us special and different from any other UAS in the market. And then that is going to allow us to go into a 3D scan deep dive, which is going to be presented by Brian. We're actually in the celebratory month of 1 year of us having announced 3D scan to the world, right? So in June 2021 is when we finally launched 3D scan. And so what we want to do is, first of all, show you what 3D scan is all about. What are the core tenets and characteristics and capabilities of 3D scan. So that might be helpful for anybody that is also new to the product. But if you joined us for that announcement and you knew what 3D scan is, then we're gonna transition to a point where Brian is going to explain all the latest enhancements to 3D scan, basically showing you how we've been improving it over the 1 year that it's been out in the market, addressing both challenges that our customers are telling us from traditional solutions, as well as just also enhancing the product itself after a year of being used by all these enterprise and public sector customers out in the real world. And finally, the second half of the presentation, we're going to transition to Peter, where he's going to talk about his real world application of 3D scan, as he leads the UAS team at the New York Power Authority. So with that, let me get going with this, very high level overview of our products, right? Skydio is, the leading US drone manufacturer and world leader in autonomous flight, right? And so the way we deliver that to the market is through these two drone platforms. So we first came out to the market with the Skydio 2 back in 2019. And so since then, actually, in the beginning of this year, we introduced a revised version of it, which we call the Skydio2 Plus. And so this is this is our most popular drone. This is an entry-level autonomous drone that still packs all the intelligence that makes Skydio famous. But it's a lightweight drone, very easy to carry. The Skydio 2 Plus, relative to the Skydio 2, came out with increased, range of performance around the battery life, around the wireless range, and it still packs, as I said, all that intelligence of Skydio Autonomy, which is the autonomous flight engine inside of the Skydios. And then we have the Skydio X2, which is the bigger sibling to the Skydio 2 Plus. The Skydio X2 is really a enterprise and public sector workhorse. It's a drone that we designed to meet and exceed the specifications of the U.S. Army around their short-range reconnaissance program, which is a contract that Skydio was also awarded this year. So we are essentially the sole provider for small UAS for the U.S. Army when it comes to their short-range reconnaissance program. And so the Skydio X2, again, it's designed to really meet all those tough requirements around being able to perform in tough environments, being built with a ruggedized airframe built out of carbon fiber and another set of composites that are really designed to withstand the elements. Again, it's also designed to even provide wider range of operations with up to 35 minutes of flight time with a single battery, up to 6 kilometers of wireless range on the X2E version. And it has a whole bunch of capabilities to operate in multiple environments around, as you can see, strobing lights. There's a variant that includes thermal camera as well as a color camera. We also have that variant is optimized for situational awareness use cases and longer standoff distances, whereas we also have a variant that we call the X2 Color that has a single sensor on the gimbal, and that sensor is optimized for up close capture. So actually really good for pairing with something like the 3D scan software for up close inspections, and we'll talk more about that later. So as I said before, what makes Skydio special is the fact that really, we are a UAS manufacturer, but we start from the software, right? Like we at heart are a software company, so that's how we design the drones inside out in a way where we started with optimizing for autonomous flight capabilities. And so Skydio Autonomy is the name that we gave to this, AI-driven autonomous flight engine that powers all of our drones, that is capable of these three core aspects of autonomous flight, which is actually seeing the world around it. And we do that through computer vision, a computer vision system that is enabled by navigation cameras sitting around the drone. And then the drone has intelligence in it that is capable of understanding the surroundings and finally able to take intelligent action based on all that input. So when we go a little bit deeper into what that means, you can see here that our autonomy means that our drones are capable of sensing the environments in 360 degrees, right? Like there's nothing that the drone is not seeing at any point in time. And because the drone is based on this computer vision system, it also makes it incredibly robust to a whole bunch of environments where other drones might fail. And this is actually going to be very relevant when we go into the topic of using these drones for inspecting environments that are energized, like the ones that Peter is going to talk about later on. So the fact that the drone is capable of operating with computer vision means that while the drones do have a GPS system on them and they do have compass magnetometer on them, they don't fully rely on those for stable flight, right? So we'll use those to complement the navigation of the drone. But if for some reason there's no GPS connectivity, or there's something that might impact the performance of the magnetometer, the drone is gonna be able to fly steadily because of that computer vision. As I said, the drone is capable of then taking all that information in and understanding it and building a real map of those surroundings, so that it's capable of doing more like recognizing subjects, predicting into the future around whether some of those subjects might be, so that it finally can actually autonomously navigate, still based on all the input of the pilot in command, but at the same time, at all times, assisting that pilot in command so that we can implement 360-degree obstacle avoidance, and we can go even beyond that, right? Like by automating entire complex workflows using this level of automation that only a Skydio can bring. And so those automated workflows are essentially what we're going to discuss with a 3D scan product, and we'll discuss that in a second. But when we say the drone can take action, is because they can actually autonomously go and plan a path to capture all the details of a particular structure without prior knowledge of it, just by us defining a volume around it. So what does this mean in terms of why Skydio drones are valuable to anybody looking at using drones? It's because ultimately all these things translate into this core important benefits for our users, right? The fact that we're using this computer vision system for navigation means that you don't need to go through the traditional calibration dance that many other drones require. And so that means that you're going to be able to get up in the air much faster. Just take out the drone, start it, and then send it into the air. And that's going to accelerate your time for actual deployment. Again, the fact that it implements 360-degree obstacle avoidance means that the drone is much easier to fly. It's going to require much less training relative to other solutions in the market, because it's going to keep you safe from those crashes, right? So the drone is going to be able to sense its environment and assist the pilot in command at all times, moving it away from obstacles, even as the pilot might give it a command that might send it into a direct collision with some object. As I mentioned before, the drone is capable of flying where other drones can't, such as GPS-denied environments where there's high electromagnetic interference, all because it's not reliant on those systems like other drones. It is using computer vision navigation for that. And therefore, the drone can get closer to capture better data, which is ultimately the goal for any professional user of drones, is to capture valuable data. And so these drones are going to allow you to get as close as you need because you have the assistance of that obstacle avoidance. And finally, automating these workflows. Again, ultimately, the drone becomes an edge device, just as they exist in many other industries. And this edge device is capable of leveraging incredible software to provide automation. And automation is ultimately what drives any industry when we're thinking about efficiencies, right? And like driving costs down. So the more we can do with fewer resources and in lesser time, the better for everybody. And that's exactly what Skydio drones do when it comes to implementing automation through a product like Skydio 3D Scan. And so with that, I'm going to pass this on to Brian for him to dive deeper into what Skydio 3D Scan is, as he helped develop it from the beginning and go through all the features.
Thank you, Mal. All right, so I want to start with just a little bit of background by speaking about the sort of status quo of the industry up to now, which is predominantly two modes of operation. The first is purely manual flights. These are typically lengthy, complicated. There's obviously a higher risk of crashing. And in most cases, you have to be a skilled pilot, which often leads to increased cost and fewer overall available resources. 2D mapping is the other common mode of operation, especially over the last 5 to 10 years. In this scenario, you're typically looking at long standoff distances, flying further away than might be ideal for the images you're trying to capture. That can lead to lower quality data. It limits your applications to those that are sort of wider area, less complex, less three-dimensional. And at the end of the day, drone program managers have not been able to scale programs as they had hoped. And to be brutally honest, like the industry has not sort of lived up to its promise overall. So with that, enter 3D Scan. So Skydio 3D Scan is the first of its kind adaptive scanning solution for fully automated data capture. So no matter the structure, the scene, the shape, or the size, we will automatically figure out what is in the scene. We will determine a flight pattern to capture a complete and full data set, and we will execute it completely autonomously. The objective is to capture that full data set with a high level of confidence, such that you can take that data, use it for pure inspection use cases, or downstream, take it to some of the leading photogrammetry software engines, such as those listed below, which we'll talk about a little bit more as we go. The key here is that Skydio 3D Scan is meant to be a tool for any worker, not just a skilled pilot. Next, please. So going a bit deeper, one of the key differentiators of 3D scan versus other products is that regardless of what you're trying to capture or what you're trying to scan, the workflow is essentially the same. So starting on the left, the first step of executing a 3D scan is defining the area that contains the structure or scene that you wish to scan. And the way you do that is you first define a floor, which is the bottom, the ceiling, which is the top, and the sides by defining some sort of lateral boundaries. And the idea is you've constructed this 3D scan area that contains the structure you wish to scan. After that, Skydio will autonomously explore that area. It will fly around it completely autonomously, and it will build an onboard map of what is contained within. Using that information, the Skydio drone will propose a flight pattern that will completely encompass the structure, achieving full coverage once flown. And just before executing the flight, you have the ability to change various settings. For those of you in this industry, these will all be things that you're used to. In this case, they'll be in 3D. This would be like overlap, side lap, distance from the structure, and resolution in terms of GSD. Once the drone is flying, you really become just, you're just there to monitor the drone's progress. You're not there to intervene. You're not there to be a pilot. All you have to do is monitor the drone's progress. And we have added quite a few tools that we'll talk about in greater depth later that allow you to monitor the drone's progress, to see how much coverage you're getting, and to see that you're getting the coverage that you set out to in the beginning. Lastly, at the completion of a flight, you have the ability to review the outputs in terms of the imagery in real time in the field without connectivity. You can also view that real-time coverage output, which we'll talk about, and you can do all of that in the field to be sure that you have got the data that you set out to capture. Next. So continuing to go deeper, within 3D scan, there are a couple of different scan modes. So the first is 3D capture, and this is really the one that is made for high fidelity 3D models or capture of complex 3D scenes for pure inspection use cases. So on the top right, that's an example of this crane structure that we've flown with 3D scan. You can see the drone has captured it from all angles, above, below, and from the sides. We also have a 2D capture capability within 3D scan, but this isn't necessarily the type of 2D capture that you're used to. In this case, this is also something that you can fly in a GPS denied environment without pre-planning, without any preparation. And of course, Skydio Autonomy and obstacle avoidance is active at all times. Next. So we wanted to talk more about some of the in-flight tools to observe the progress of the flight and ensure that you're getting full coverage. So the top right shows something that we call the Augmented Reality Observer, or AR Observer. This allows you to set a sort of third-person perspective that you wish to monitor the progress of the scan from. This is incredibly useful for 3D objects. Like in this scenario, this is an example of a telecom tower being scanned. The operator chose where they wanted to view the scan from, and then we will project the drone in augmented reality. And we will also project this thing called the AR coverage mesh, which is what shows you that you're getting the overlap and the side lap that you specified initially. So top right, what you're seeing is the drone flying around the tower along the automated flight path, and you're seeing the coverage mesh turn from yellow to purple, which is indicative of you getting full coverage. In the bottom, this is another view of that AR coverage mesh, but this is from the perspective of the drone itself. You can easily switch between either one of these at any time during the flight. And the key is that you're an operator, you're not a pilot, you're just monitoring progress, gaining confidence that the data you set out to capture is being captured. While flying, the only other thing to think about is once the battery gets low, and in this case, we will also handle that for you. So the drone will automatically return to the launch location or another location that you have preset at the beginning of the workflow, you can swap the battery, automatically take off and resume. And the key difference here between what you may be used to is that the drone will continue where it left off, even if you're in a GPS denied environment, such as underneath a bridge, next to a building, or some other challenging environment. Next. And then lastly, we spoke a little bit about how you can verify coverage in the field before you leave, once again, to be sure you've got what you set out to capture. We have this tool called the Edge Model Viewer. This runs on the drone itself. It is available minutes after landing. It allows you to view the images in full resolution. It allows you to view that augmented reality coverage mesh. You also have the ability to pick a point on that coverage mesh, which is sort of a rough 3D model, and you can view all of the images contained within that point. And that is a really quick way to do a field inspection in near real time. Make sure you've got what you need and or make a call right there on the spot. And to reiterate, we are compatible with all of the leading photogrammetry engines, Drone Deploy, Reality Capture, Bentley, Esri SiteScan, and Pix4D. Next, please. All right, so Mao mentioned this at the beginning. It's been about a year since 3D Scan launched. In that time, we have launched support for our entire product line to include S2, X2E, and X2D. We've also released 3D Scan on iOS and Android. We have also released some completely new scan modes, starting on the next slide. So the first one, by popular demand, is 2D GPS capture. We believe that this is one of the simplest possible capture modes out there, with the most streamlined UX. This is what many of you are probably used to, where you specify a pattern on top of a map. We will fly it automatically, just like all Skydio offerings. You have full obstacle avoidance and the highest levels of safety. Next. More recently, we announced 3D tower capture mode, which is optimized for telecom towers, but also just predominantly vertical structures. This is applicable to stacks. This is applicable to distribution towers, transmission towers. You're going to hear more about this from Peter later on. One of the key differences here is that rather than specifying a 3D polygon that encompasses the structure, all you have to do in tower mode is specify a center and a radius that encompasses the tower. We will figure out what is within that volume. We will propose an automated flight plan and we will execute it automatically. One thing I want to call out here is that you do not have to be precise in how you specify the center or the radius of this object. Once the object is encompassed by the volume, we will capture it and we will get full coverage. Now we'll show you a video that better illustrates the power of 3D tower capture. let's continue to go a couple of levels deeper here on functionality. So in addition to these new scan modes and 3D tower capture, we have also released numerous features with 3D tower capture, but many of them apply across scan modes. The first is something we call Optimize XY. So the way 3D scan works today is we propose a flight plan that is across sort of 3 axes. So we'll first fly Z slices, which are sort of orbits around the structure. Then we will capture Y contours, which sort of go above or underneath a structure, looking up, and Y contours, which are 90 degrees to the Y slices, but the combination of the 3 will ensure full coverage of any 3-dimensional object. However, this also can result in excessive imagery, or in some cases, redundant imagery of parts of the structure that you've already captured. So on the next slide here, we'll try to detail that a little bit more. What you'll see here on the left is what I just spoke of. So you have the ability to turn on all or some of the Z, Y, and X slices, depending on the sort of structure that you're scanning. If you turn on X and Y, which is illustrated on the right, we will ensure full coverage of the structure without capturing redundant imagery. So a great use case for this would be scanning a telecom tower where you do want to capture imagery looking up at the antennas at the rad center. If you turn on XYZ and optimize XY on, we will capture the tower in the most efficient way possible. We will also capture imagery looking up, but we will not capture an excessive amount of imagery while still getting full coverage. Next, please. All right. 4 other additional enhancements that have been recently released that we're excited to talk about here. So the first is take best photo. So the challenge here has been if you're flying a structure or the facade of a building or even a tower that is very close to another building or a tree or something like that, in the beginning, we would sort of skip capturing of that imagery because it obstructed with the flight path. With take best photo on, we will take the best photo that we can. So if there's a very, very small space between the structure and the tree or another structure, we will fly in between those things. We will take the best image that we can, again, with the overall objective of always ensuring we get the best coverage possible. Safe distance, that is another feature that has predominantly been driven by customer feedback. For example, when scanning a self-support telecom tower or a lattice structure, sometimes the drone during the exploration phase of the 3D scan or during the scan itself would fly into that structure. It would fly through the trusses, which wasn't always desirable. Safe distance allows you to sort of increase the safety bubble around the drone, preventing it from flying into smaller spaces. This is also helpful if you're flying like particularly complicated large structures. If you increase that distance, it will speed up the explore phase and give you a more efficient scan for large areas. Second from the bottom, something called extend capture area. So 3D scan right now predominantly is optimized for looking sort of from the outside in. We now have this capability to turn on extend capture area to look outside the lateral bounds, above the ceiling, or below the floor. An example use case here would be scanning a telecom tower with a structure below that you don't want to fly into or very close to. So you can enable extend capture area below the volume. So the drone will capture the tower. It will then look down at the compound, which is especially useful if you're building maps or if you're also using ground control points as part of your reconstruction. Lastly here, for those of you with X2 color thermals, which is the X2 variant that has both a color and a thermal camera, you can turn on thermal capture during the scan, and we'll capture a thermal photo at the exact same time that we capture a color photo, which can be particularly useful, especially for commercial property inspection and in some cases utilities. Next, please, Mal. All right, before I hand it over to Peter, the last thing I want to call out is we have also launched the Skydio Cloud since 3D Scan came to market almost a year ago. A key piece of that has been our integrations with some of our closest partners. So you can leverage 3D Scan you can leverage Skydio Media Sync, which gets your data to the Skydio Cloud without touching or fumbling with SD cards. And then you can seamlessly transfer that data in the cloud from Skydio to Drone Deploy or to Optelos for processing and downstream analysis. So with that, I'm excited to hand things off to Peter to talk about his awesome UAS program with the New York Power Authority and how he's using 3D scan.
Good afternoon, everyone. Hi again. Next slide, please. So I've been at my position now for about 9 months, and I'm retooling New York Power Authority's idea of how to use UAS. We always talk about it's easy to fly, it's easy to capture, but what do you do with that data afterwards? This is something I'm taking great pride here at the Power Authority to help to achieve our Vision 2030 initiatives, which means we want to be a digital utility for the future. How do we cut down the risk? So mission management software is a big portion of our day-to-day lives. How do we plan our missions? How do we know where our pilots are? And moving forward from that. So we have our missions planned, we captured all that data. How do you manage all that data? How does someone in a different office get to use it? And it's one thing if I fly one mission for one use case, but from what I'm noticing here at the Power Authority, one mission can solve 9, 10 different questions to different departments. They just need to know that the data is there. So data management has really been the focal point of our program. From there, we can bring it into different programs like image processing, so we can start building our libraries. So this is our 3-prong solution that I'm instituting here. Next slide, please. So before I got here, we were all, the authority was really big on capturing videos. And a lot of drone manufacturers have some pretty good videos. But engineering-wise, they're useless. No one really wants to watch a 14-minute flying video of flying near a tower. You want to know what's broken, what's not broken. Quick, simple, straight to the point. So on the picture on the left, one of our line guys took a picture of this, and I was like, Scott, I don't know what I'm looking at. And he zoomed in and he sent me another picture as you see off to the right. That's ease, that's quick. Zooming in editing is a lot quicker than trying to cut down a 14, 15-minute video at high resolution. And then how do you store all those videos? Photos are smaller, quicker, and easier to send. We can text this out to other engineers or other departments that need to know. Next slide. When we take just a photo and you take a boatload of photos, you can get these point clouds. Right now, we do use Drone Deploy for some of our applications, but we're moving more and more to site scan internally. And I'll talk about that later slides to come. But when we start getting these point clouds, this is where we can start doing volumetric measurements, elevation differences, the heights, even tagging problems that we might have with the structure. So instead of New York Power Authority is across the whole state of New York, to have engineers from New York City to come up here into St. Lawrence, it's time and money to come and check out a problem. If we can do a quick map or a quick little scan of an area, everyone can see it right then and there in front of them in a digital twin type of environment. And this is where we really want to focus, because if we can start improving our digital twins, we can save more time and money on the back end of it. Next slide, please. So tower scan has been, 3D scan has been a very big, important point for us here. New York Power Authority is working on Vision 2030, and we're updating our power grid for New York State, downstate to New York City, and it's called SmartPath. We are scanning every single new tower that we are building and keeping the digital twin. What this is doing for us is, A, we know what it looks like when we first installed it. where I'm aiming for my project to get to in the winter is before the winter, we'll do another scan. Before first snowfall, we'll do another scan. After the tower's frozen solid and it thaws out, we do another scan and try to do predictive maintenance instead of reactionary maintenance. For this, our guys have made a little procedure on how to do this. Now everyone's like, well, how long does it take to scan one tower? It's 15 minutes. Our pilots are always paying attention, but like they stated earlier in the slides, it's not scalable. If I'm required to go and fly these complex motions and create a 3D model, we all know how difficult that is. Or a point cloud, it's very difficult if you don't know how to operate it. And we can't go out and hire 10 professional pilots because they cost too much. Their drones have been very effective in cutting down waste of time and moving forward with their software. Now, you can see from the progressions, we have our procedures on the left, the final model, but you can see every photo taken of that. Through there, you can annotate. This was done through Drone Deploy, if I'm not mistaken. These photos come off of, and you can annotate markers and send those out to other individuals within your group, talking about severity and so forth. But to have a model from day one, and I know I'm talking about in the future, but 5 years out, have the model of what it looks like today and watch the corrosion, the erosion, and just problems forming over time. This is how we can benefit for the future, not just for today, if that makes sense. Next slide, please. So like I said, when we go up, we can add certain marker points. As you can see on the lower left-hand corner in the picture, there are 3 triangles for 3 problems to a new structure that was being built. This, we add severity of how complex, how major of a problem it is. Is it something to be aware of for future degradation? And that's how we're using the modeling. Next slide, please. Oh, there we go. See, perfect. From here, everyone can actually see the pictures and refer back to what it is. So the structure is 36/2E. And this was an inspection we did with the aircraft. The software for this mission took us about 22 minutes. It was a 2 battery change because up in St. Lawrence, it's quite windy, quite cold. Batteries really don't like that so much. But once it flies it and it comes back and it takes right off and it continues right to where it stopped taking its photos, which has really put a lot of our new pilots at ease because they don't need to have my flying skill or some of your advanced pilot skills that are needed for other missions. Next slide, please. So what are the benefits of this? This is actually from one of our engineers out in the field, okay? Saving time, the safety factor, you know, when it's really cold out up here in St. Lawrence, it can get into 12, -10 real easy. When you're dealing with the elements and trying to fly these complex structures, it adds a lot of undue stress on the pilot. When the computer is doing it and the operators are just monitoring the aircraft while flying, it's beneficial. They're at ease, they're more comfortable, easier to build confidence, so they're using the equipment more and more and more. Next slide, please. So some other things that we're using is our hot stick line persons for just quick visual inspection. With the Skydio, they're able to fly Skydio. They're really easy to fly up and close to the tower without fear of falling into the tower. The buffer zones are pretty good. And as the guys start getting more and more comfortable, as the people start getting more and more comfortable, they start flying closer and closer to the structure, relying on it. But as you can see with the picture on the left, the original doesn't make much, it's not any good. But when they're able to zoom in from that far away and still see the necking of the bolt, that's where we see the benefits. We are also working on our procedures on the upper right-hand corner. How do we take the picture? How do we make sure that Okay, person in St. Lawrence is flying a mission, but how does that person in our other location, how are they both flying it the same exact way? It's creating procedures. And especially when it's a software that we're writing these procedures for, it's really easy. Next slide, please. Here's another testimonial from the same hot stick line person who took those photos before for us. It's been beneficial for our teams bringing in this new tool. Okay, like how I've been growing it internally, I can get in more trouble with my cell phone than I can with these drones. The geo-fences have been a nice, relaxing effect. They don't limit us like some other manufacturers, but the pilots can say, hey, there's a pedestrian walkway over here. This is an absolute no-fly zone, and set up a wall. The drone won't break it. I've tried doing it, haven't been successful yet, but we'll wait and see. Next slide, please. So great, you have all this data, you have all these photos, you have all these maps. How can you bring this into your workflow? Well, we use Esri here quite a bit at the New York Power Authority, and we use ArcGIS for our GIS system. We're able to pull in our new maps into our ArcGIS. And as you can see in the center photo, we overlaid our center lines from our LiDAR scanning. Next slide, please. We took this one step further. So what we saw in the first slide was a 2D map. We're scanning them in the third dimension, and we're still able to import the modeling, the point clouds, into ArcGIS and insert our center lines to the new models. This is a game changer for us, yet again, because you can visualize the product, not see a 2-year-old picture, a 2-year-old map from Google Earth, but an updated map as frequently as you'd like. Next slide, please. So what are some use cases for this? Well, in ArcGIS, we have generic towers, as you can see in yellow and in white, that we can put in place. Well, now we're able to take that point cloud and actually bring in the actual tower. Before, we used to guess where danger trees are. Those are what you see in red. Now we're actually able to pinpoint where the danger tree is and put in a generic logo, a generic icon of a danger tree. But how we used to do it is we send photos out to the guys and say, hey, in that clearing over there somewhere, there's a danger tree, and go cut it down. Sometimes they didn't cut down the right tree. This happened more frequently than I can actually imagine. Now with these GPS points, we can actually send them the lat and long to the guys in the field, actually make it show up on their ArcGIS system from there, and then they cut down the right tree, which has been a really big benefit for the short term for us. Next slide, please. So where is it going? A multi-drone solution is what we're aiming for. Right now, the FAA, yes, doesn't allow us with regulatory, but in our opinion, the Skydio, the facts are that they're moving. Their autonomy is really robust, and we trust it. We fly it inside our switch yards. While they're energized, which is a big deal. Some other manufacturers, we can't do that. Guys before in prior years have attempted it, and it's never ended well. Skydio, we're flying in 765 kV yard while it's energized. And the modeling has been really beneficial for current projects and future projects that we're working on. Next slide.
Perfect. Thanks, Peter. Thanks a lot for that. And, if you can actually stay on, because we are now going to move to a live Q&A part of the presentation. So we're going to have questions for all of us. Our colleague Sean has been answering on the Q&A chat as we go, but obviously he we're saving some questions for the live Q&A. So, I want to start with you, Peter, because I think everybody wants to know how this is used in real life, so we can answer some of the questions for product later. But I want to start with you. So, one of the questions here that I wanted to touch on is, given your U.S. program experience, can you talk a little bit about the differences training your team based on using the Skydio drones and something like 3D scan versus other drones that you've used in the past that haven't had these capabilities?
It's kind of funny how this webinar fell out because we're actually doing a training this week. So whenever we purchase any of your drones, we buy the training to help us get our pilots some confidence. And we go out, we fly the drone for a day, which is fun. But then when we actually get into 3D structures and modeling, that's where we're spending a lot of time actually in the field with the use cases, which has been benefiting us. Honestly, 3 days with one of our advanced mapping teams, and our guys are spun up to date pretty quickly. The models have been it's like sharpening a knife. The more they fly, the better they understand how the software works, the better the final deliverable is, and that's the key to this all. Does that make sense?
Sounds good. Yeah, thank you. And one more question for you. Somebody's asking about, if you've seen any issues with operating with drones around, energized environments that you're flying around.
This is actually a great point. EPRI, back in December did a study where they told us that the energized lines did not have any effect on your systems. And so from that, we took a deep dive and we did an experiment, and we haven't seen any problems yet come from this. We have a rule in place where it's only your aircraft is actually allowed to fly in our switch yards while it's energized. And it also about cybersecurity and some other things. Having an American-made drone makes it a little bit easier.
Perfect. Awesome. I'm just checking on time. So I think I'm gonna have some more questions for you, but at the same time, I want to cover some other things for products. So I'll come back to you. I'm gonna ask myself this one because it's a little bit about what we do on our team, which is around a little bit of packaging and pricing. So the question is, are there any new capture modes available as software updates, or do you need to buy the new features? And the question is related to, for example, 3D tower capture as a new mode of 3D scan. The answer is great for all of you, which is all of these have been just software upgrades, right? Like, so they're like anybody that has the 3D scan software is getting all the functionality that that Brian was describing around new capture modes, such as 2D GPS capture, 3D tower capture. All of those are just, being sent into the product, and everybody's experiencing those. So I think that's a great answer for you. Brian, I wanna ask you one, and bring you here as a PM for 3D scan. So there's a question here that says, do you know if there's a way or a future development that would allow automated flight for a series of photos at a larger surface to distance value, say for a single contour slice?
Yep, this capability, and this ties in nicely with Mao, what you were just speaking about. We will continually be updating the capability of 3D scan over time. This is a sort of feedback and question we get fairly frequently. This is absolutely on our radar. I have no specific timing that I can disclose in this presentation today, but that sort of capability is on our radar for sure.
Perfect. I think one here also a little bit about, safety of operations. Somebody says, well, for those of us in the US that are constrained by FAA regulations, is the software aware of, pedestrians, traffic, or is there a way for us to pause the flight to to wait for traffic to pass. Basically, they're concerned about how to avoid anybody that is around and they can fly over them.
Yeah, it's a good one, and an important one in challenging environments. You can always pause the 3D scan, 2D capture, 3D tower capture, any capability that is autonomous, any autonomous motion within the software can be paused and resumed at any point in the workflow, exactly for that reason.
Yeah, and I think also, like Peter spoke to this for a second, but there's also the geofencing capabilities that we're adding that also allow you to, I guess, make sure that you're operating within a safe environment, right? So as long as you can contain your operation outside of what might be more risky, that also is going to help. And as he said, geofencing is working well for him.
Yeah, and maybe I can just jump in there real quick. There was a question I saw come through just recently about keep out areas. Right now, there is not a explicit functionality to specify a keep out area within the volume, but there is a pretty advanced capability to keep the drone within the scan volume, within the sides, below the ceiling, or above the floor. And I think that was mostly what Peter was speaking to.
Peter, I'm going to ask you another question here. Checking on time here. We're good. This one seems good. So the question for you is the reporting and defect tracing interface that you've shown proprietary, like for example, like somebody like Optelos, or is it something that was developed specifically for NIPA in your organization?
So it depends. In one software, Drone Deploy, you can actually label and set the severity and send it out to someone. In SiteScan, you can mark it and then you can add a footnote to it. So that's how it's done there. But it's really meant when you share your model, if it's in through ArcGIS or however you're sharing your point cloud, anyone can see those markings and those notes to it. That's how we're using it right now. We're trying to fix it to make it a little bit, send it directly to someone through an email with just the images of the problem. But that's, yeah. Hope that answered your question.
Thank you. And Brian, I think we're gonna do the last one here. This one's gonna be for you. The question is, what types of structures am I able to inspect with 3D scan? And I think you touched a little bit on it, but I think it's worth just reiterating.
Yeah, our initial goal was to build something that is applicable for essentially any structure or scene. So in construction, this could be under construction buildings. In the sort of the DOT segment, we're talking about bridges and infrastructure, utilities. You've heard a lot about that today: distribution towers, transmission towers, substations, that sort of thing. Telecom, obviously, we have highlighted, but essentially any sort of solid structure that is accessible, we can usually knock it out. The one limitation I'll call out would be extremely featureless, shiny objects. But outside of that, it'll work on just about anything.
Awesome. Well, thank you, Brian. Thank you, Peter. I think we're coming at the top of the hour. So before I wrap up, I just wanted to point everybody out to this particular slide. We have some important resources here for you to learn more about Skydio on our web. We have tons of articles on our blog. Like, we're super active on our blog in terms of updating everybody on the latest capabilities or bringing stories like the one from Peter to that blog to tell them in greater detail. If you're interested in purchasing a Skydio for individual consumption, we also have the shop right in there. If you're interested in the enterprise capabilities that we talked about today, then you need to reach out to us in the contact us form so that you can be put in touch with our enterprise sales and start discussing how an X2 and 3D scan might fit your program. And we also have something going on right now for anybody that is interested in giving us your feedback. We have a product survey going on. We want to learn how people are using drones today beyond just Skydio. We want to know how drones are useful for your programs. And we want to use that information to improve our products and bring to market things that are extremely useful for everybody. So it's a short survey, it takes about 10 minutes, but it's going to be super helpful for us to inform how we should be developing products into the future. And so with that, thank you everybody for joining us. I saw a good attendance, good interaction. So Thank you for that. I'm going to send this back to Kelsey to wrap up.
Excellent, thank you. And I just have a few housekeeping notes to go over before we officially close out today. If you could please fill out the short evaluation form that will appear once you close the webinar, this will help us better serve your needs in future webinars. And as a reminder, I've had many people asking me, the on-demand materials will be emailed to everyone within 2 business days, and these materials will include the link to the recording of today's presentation. And thank you again to the Skydio team for a great presentation today, and thank you to all of our attendees for taking the time out of your busy days to join us. This webinar was brought to you by Commercial UAV News and sponsored by Skydio. Thank you all, and have a great day.